So, hello everybody, this is Ramit Dhiman from Ramit Engineering Works. As you can see on your screens, it's a Uni-t digital storage oscilloscopes that is of bandwidth 100 MHz and 1 gig samples per second. So let's unbox this box and see what's inside this. So it's time to unbox. First we open up this lid. So here we have the power cord here. So here we have the two props, as you can see, that is color coded. Here you can see the branding. And here is my oscilloscope. So here's the oscilloscope from Uni-t, and here's the certificates and download instruction manuals, as you can see on your screen. And here is the certificate of calibration. It's a manufacturing year, as you can see. As I focused on this thing, it's March 2024 manufacturing date and its inspection date. Here it's the other thing we had, it's calibration certificate. It's a certificate of calibration from Uni-t. As you can see, here we focus it on. Here you can see it's a certificate of calibration from Uni-t Technologies China Company Limited. It's a model number utd2102cex+, and here it's the date of calibration. It's 2024 or 4th of month, and it's 10th of date. And it's also here you can see the calibrations meters we have used for calibrating this, and Uni-t used calibrations of Fluke multimeters to calibrate this up. You can see it's the model number of Fluke, that is American company. It's a Fluke 9500B, and if I translate these things up on the translator, and it says that everything is perfectly calibrated with the tools of quality standards of Fluke, and everything is perfect. So let's start this machine. You can see on this manual, here is this QR code. As you can see on your screen, you can scan this code up to download the software for this oscilloscope, and here is the search options and other materials and manuals. You can download PDFs from this website. So let's start this oscilloscope. So here it's the first look of this oscilloscope. You can see the beautiful look. Here it's the brand name, it's Uni-t, and its model number, it's utd2102cex+. Here it's named as a digital storage oscilloscope. Here it is written as it's a bandwidth of 100 MHz, and the memory depth is 1 gig sample per second, and the memory depth is 64 kilobits per second. So here is the pen drive option slot. It's you can share this screen up with the pen drive screenshots. It's a print screen option you can use here to print the screen. Here it's two channels. It's channel number 1, it's channel number 2. It's a triggering function, and here is the prop compensation knobs, prop compensation points. As you can see, here it's a power button. On the top of it we have the power button. Here it's a beautiful handle here, as you can see on your screen. And on the side, it's left hand side, we have the power cord option. Here you can see it's the pass fail output option. It's a connector for connecting to the laptop or PC. Here is the lock. So it has a built-in power supply and fan here. So let's start this up. And by connecting the power probes, here you can see it's times 10 and times 1 probe, as you can see, from Uni-t company. Now we connect these probes. Make sure that the oscilloscope is closed and it's off state. When we put down the probes, we just open up the probes. Here we have the colored probes. We can use these colored stickers, as you can see, that is comes with for the arrangement. We have the another second channel probe. So for first channel we have this sky blue color, and then we have placed this sky blue color, and here the similar one is placed on this type of probe. You can place any colors you want and gently press it on down by connecting this BNC connector to the same slot. We just put it up and slide it down. Now we have connected the probe 1. Now for second probe we have the red color is used. We also used the orange ones or green one. So we have used this. We just checking out these cuts here and then put it in this BNC slot by gentle pushing. So we connected both the probes. We also had this type of screwdrivers for probe compensation. We just open it up. This all accessories comes with this oscilloscopes. Here it's a plastic screwdriver with the edge of steel. We just use in this video for the. So now it's time to open up and press the power button here. Here you can see it's the Uni-t logo on this. So it's a distortion here, we can see. We just close the math function. So we're taking down the closer version. So now it's time to start up this digital storage oscilloscope. First of all, we check all the things on the table. We have probes connected and press down the power button. Here you can see something which runs on this instrument, and there is something kind of relay ticking sound. I think it's a relay. So here you can see, do not touch right now, do not touch these BNC steel connectors. We have used. So now channel 1 is open. We close it down to channel 1, so the light is go away and the channel 1 is closed. So before every measurement we have something to compensate. We have to use this probe compensation pins to measure the waves that is come out from the source. We have to measure. So first of all, we just take the probe button to times 10. It's times 1, it's times 10. As you can see here, you can see it's a times 10, and on the another pin it's times 1. It's now it moves to times 10. So we have to see the channel 1 signal, then we press the set channel 1. We also similarly we have to use channel 2. We press the channel 2 button. So we have 2 channels side by side for measuring purposes. So this is vertical position knobs and this is horizontal position knobs. We just make it, first we set up the channel 1. We have this state, we have the channel 1, and we use channel 2, and here we have the channel 2. So we have to check the signal accuracy from channel compensation. Before every measurement we just compensate the probes. We have just placed these 2 things side by side on the probe compensation points, and the earth pin is connected right down on the earth button. We have similar. So now we have two scale waves. As you can see here, it's probe compensation point. We have approximately 3 volts of wave with 1 kilohertz of frequency of this wave. So now we check it down. So first we close it down the channel 2, and we have only channel 1 on my screen. As you can see, there is no perfect scale wave on this screen, so we compensate this with the screwdriver we have placed here. So we press the auto button here, so this oscilloscope shows the 2 waves. We close the channel 2, and here you can see, so we change the position to the center point of this oscilloscope and increasing the time. Here it's the perfect. So we make it perfect scale wave we have to use. So the blue color is of this, and we just place the screwdriver on this probe and set it down to perfect scale wave. As you can see here, we have made. So as I move the clockwise, we see that the scale wave is the sawtooth wave, and it tends to be exponential, but we just make it perfect square. So now it's perfect square wave. So similar we done with the second channel. We just close down the number 1. Here it's scale wave all. We just make it perfect square. So here you can see it changes as I move this screwdriver up. So now we change this up. Now we place this here. We have both the channels, channel number 1 and channel number 2. So now this oscilloscope is ready for measurement, and this thing we used right now is the probe compensation. We just periodically change and compensate the probes as we measure the signals. So here we can see it's a probe of 3 volts 1 kilohertz wave. We just measure. Here you can see it's the measure. We have the all parameters. We press the F3 button. Here you can see. So here you can see it's parameters of this wave. It's maximum amplitude of 3.050 volts, as you can see. Here you can see it's 3 volts at 1 kilohertz, and this here is frequency. If we use the frequency, it says it's 1 kilohertz, as you can see. So here is zoomed out, so it measured perfectly. So if we want to check the parameters, we use this measure function. Here it's the measure. So these are the perfect measurements as with this probe compensation we get. So right now we have the parameters we have with the related to waves, and it's an amplitude of 3.057 volts, and it's peak to peak 3.240 volts, and its middle of this is 36 or 37 millivolts. And the another parameters are frequency 1 kilohertz, and here's the duty cycle, it's 50%, and the area is 20, 18, 22, it's changed simultaneously. So these are the parameters we have to find with, and just press the menu button and clear it all. So now we just check the version of this oscilloscope we get in utility. It's auto set, we have it. Now we change the system configurations. It's a system information. Here it's the model number and FPGA number, it's hardware number. So from this help, if I press the help button, we just get the help of every knob. Here you can press this button. This button gives the information about this button only. If I press the display, the help button keeps us by showing the function of this button. And if I press this button, it's a multi-purpose key, as you can see. So again we get this up. So this oscilloscope comes with the math function. Here you can see if we had the math function of this, we get the x and y parameters here. Press the negative, we just check the voltage on this. We press the negative and connect the negative with the negative probes, end of probe, and the second positive of the positive probe. Here we select the channel 1, the coupling is AC coupling we used. Here you can see it's 9 volt. We have used the measure function from here. We use the all parameters. So the biggest advantage of this oscilloscope is that it is connected with PC or laptop. We just plug it down and connect this cable from back of this oscilloscope and power this thing up. So here you can see the waves. We connect it to my laptop and opening up, just download a software from Uni-t website. And open it up, the device manager app. The same signal of this screen is appeared on the screen of my laptop. So here you can see we connect the USB function. I just focus it on this. We just use and select the DSO and double click on it, and we check the open DSO and place the click button here, and here you can see we just use all the parameters from this. If I used the channel 2, as you can see, my oscilloscope works from my laptop. This is the main advantage of this oscilloscope that make it different from other competitors. As if I want to close it down the channel number 2, as you can see here, the channel number 2 light is blinking, and I put my laptop, and I just close the channel number 2 by pressing it 2 times. If I want to close the channel number 1, we just press it down 2 times and the channel number is closed. And we use this function from anywhere in the world by using this. If I work from my home or with my team, I can use this oscilloscope from everywhere in the world and share my information with my another engineering friends or technical hubs and technical colleagues. So right now we have the probe compensation again. We used, just press it down and connect it with the 3 volts 1 kilohertz wave, and the second ground pin is connected to ground, and we just press it down from these by do not selecting and connecting and pressing the buttons on oscilloscope. I just use my laptop as a hardware and just connect. Here you can see the wave. Here you can see the waves are similar to this one. I just press the auto button from my laptop. As you can see, as I press the auto button, everything is standstill. I am just measure the waves on my screen. So here you can see all the functions are working here. As I press the math button, it just turns the math function, and here you can see the red lines. These are the math function. We just close it down by pressing it 2 times, and here are the knobs. We just change every parameter from my laptop, and here also the vice versa is also possible. If I change my knobs here from this side, right now it shows the keys are locked. If I try to unlock, but I think it's for security purposes. When I connect it with the laptop, we just have one-way communications. So I think it's the more beneficial than other things at this price range. So if I close it down, the auto button here, I think right now it's locked. But here my laptop is also work as DSO. The hardware is shifted to my laptop, and the overall control is shifted to my laptop. If I use it with my team, they can work with me jointly and share my work with another countries and my friends and colleagues. So this is the most important function of this oscilloscope. So as it closes down, just close it down, and everything is again unlocked. We use similar functions again and again. Here it's the perfect square wave right now. So we use the probe compensation repeatedly in our work environment so that every measurement is full of accuracy and precision, so that everything is measured perfectly fine. So here's the Uni-t with DCSO opening and overview of this DSO. It's Uni-t utd2102cex+. I hope you enjoy this video, and this instrument is very much useful for my future projects and future measurements. So if you have any repair works, please contact my numbers. I just fulfill your requirements by doing my best of my work. So thanks very much. I just power off my oscilloscope. So thank you very much for watching.